Friday, we talked about the graphs of the sine and the cosine curve, okay? So, what is the definition of sine? Sine is opposite over hypotenuse, or
X over
y over r, right? So what we did was we compared what? We compared the angle measures, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we used the ratio y over r. At 0, and now when I'm talking about 0, I'm talking about here. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So the definition of sine is the y value over the r value. So the y value is 0 here, so 0 and r is 1. 0 over 1 is, what's 0 over 1? 0. So that's this point right here. Pi over 2 is 90 degrees. The y value is 1. 1 over 1 is 1. So over pi over 2 up 1. At pi, the y value is 0. 0 over 1 is 0. 3 pi over 2, y is negative 1. And at 2 pi, it's back to 0. So this is what basically, without going into a whole lot of detail about the 30s and the 45s and the 60-degree angles and the ratios in between, this was the shape of the sine curve from 0 to 2 pi. From here, the cycle repeats itself. So 0 is the same as 2 pi. These two were the same. And I should put negative 1 and 0 here for you. So these two, the cycle is going to repeat itself. So from 0 to 2 pi is one complete cycle, one period. Now, how many increments are there? Well, from 0 to pi over 2, 0 to 1, right here, this is one increment right here, one change. And then we went, this is the second increment, and this is the third increment, and then the fourth increment. From here, it's going to repeat itself. It's going to go above, on, below, and on. So the period is from 0 to 2 pi on the sine curve. So it started on, and it went above, on, below, and on. Now, without going and redoing everything, do you guys remember the ratios for the cosine? What was the first one? At 0, pi over 2, pi, 3 pi over 2, and 2 pi. Do you remember what it was for 0? 1. Do you remember what it was for pi over 2? It was 0. For pi, what was it? Negative 1. 3 pi over 2 was 0, and 2 pi was 1. What did this thing look like? What did it look like? It looked like a cup, right? And again, there are 4 increments here. Here's 1, here's another 1, 2, 3, and 4. From here, it's going to repeat itself. So there's 4 increments, 1, 2, 3, 4. The cycle again, the period, is from 0 to 2 pi, and then it repeats itself. So yesterday, or actually Friday, what we looked at was stuff like this. Okay, we called this the A value, and we called this the D value. Do you remember what each of these did?
D.
What did A do? What did A do?
Stretch the graph.
It vertically stretched it. We called this the amplitude. This was a vertical stretch by a factor of 2. And what did this D value do?
Move the x-axis down.
Yep,
Up or
it
down.
went down, this one would go down 3. So what it did was, if we took our graph, and we went from 0, we went pi over 2, we did the same 4 increments, pi, 3 pi over 2, and 2 pi. This one is a shift 3 units down, so you'd have to go 1, 2, 3, 3 down. And we drew a new x-axis here. So we started here with an amplitude of 2, we would go on, we would go above, and then 2 down, and then back on. So it looked like this. Something like that. Sorry, I kind of did it sloppy. It should be right there. Okay, so 2 is your amplitude. How high off the x-axis are you? You're 2 units. That's that. What if this thing were a -2? What would I have done differently? You would go down 2 and then on and then above, so the thing would be going backwards. That's what we did yesterday. Friday. So today what you're gonna do is you're gonna look at, we talked about the A value. This is the notes for today. We looked at what the A does. The A measures the amplitude, or how steep the graph is. The D value shifted it up or down. What you're going to do is look at the B value. Where is the B value going to be? The B value is going to be the number in front of your X or your T. Sometimes we use X, sometimes we use T. So this is what I want you to understand here. Check this out. We're going to do this example together. Can anyone tell me what the A value is? This is the like recipe. A is the number in front. That's going to tell you your amplitude, and in this case it's a 1. The D value is the number at the very end here, and in this case it's not shifted up or down. So there is no vertical shift. These are the 2 new pieces right here. Your period normally for a sine and cosine graph is 2 pi. Usually this is a 1. Like the section we did Friday, the number in front of X or T was a 1. So what you're going to do, you're going to take 2 pi and you're going to divide it by the B value. And in this case, it's not 1, it's a 2. So what is 2 pi divided by the B value? B is 2 in this problem.
Pi.
And you get pi. What this means now is our graph is going to complete 1 full cycle by the time we reach pi. So if you look at this graph that we did a few minutes ago, we went from 0 to 2 pi in 4 increments. Now I'm saying by giving you this problem, this is going to make it go quicker. I am going to go on, above, on, below, on, by the time you reach pi. So this is my graph. I'm going to use a different color so you see the difference. I would be going on, above, on, below, and on. So I'm going, this cycle is going to happen, the 4 increments are going to happen before we reach 2 pi. Actually, it's going to happen by the time we reach pi. So really what is going on here is we just did, by the time we went to 2 pi, we did this period twice by changing this B value. So what you're going to do, because it's really hard to read these numbers, we're just going to change our x-axis. So what I want you to do, I want you to take 2 pi and find the B value. You do 2 pi divided by B. You're going to take, how many increments did it take us to get from 0 to 2 pi? How many sections were there? There were 4. So you will take this number that you get here, your period that you got here, and you're going to always cut it into 4 parts. So now, instead of your increments being pi over 2, pi, 3 pi over 2, and 2 pi, you're going to count you're gonna count, starting from 0, you're gonna count by pi over 4. That is what you need to do. So what we're gonna do, I'm gonna name my y-axis as 0, pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. What is 4 pi over 4?
Pi.
It's pi. So what we're gonna do this entire cycle by the time we reach pi. It looks like this. So if you don't know the cycle and what it looks like for sine, from what we did on Friday, you're gonna have a hard time with this. So it looks like this. Now, if we were to have used the same x and y axis that we did on Friday's homework, so in other words, like these ones, this, your graph would have completed the cycle by the time you reached pi. So in other words, let me get a blank one. So if I use this right here, this is what my graph would have looked like. So it would look like that. That would be one cycle versus from here to here. So what's happening to your graph? It's being horizontally compressed by a factor of a half. Okay? Let's flip it over and see if you can do the next one. Okay, this one says the graph of negative cosine 1/2 t. This we're concentrating on the b value. This is your b value. That is gonna change your period. So instead of it being from 0 to 2 pi, it's gonna be something different. Let's take a look at it. Our amplitude is a 1. So in other words, how high off the x-axis are you going? It's 1 unit. The period, you always take for sine and cosine, you take 2 pi and you divide it by the b value. Can you tell me what the b value is here?
1.
It's 1/2. This is what, b is 1/2. The number in front, the coefficient in front of t is 1/2. So 2 pi divided by 1/2. Now, how do you do this problem right here? What's 2 pi over 1/2? Be careful.
4 pi.
You get 4 pi. Thank you, Nick. How'd you get that?
It's the reciprocal, you multiply by the reciprocal.
Very good. So now, it's gonna take from 0 to 4 pi to get through those 4 increments. How many increments are there in a sine and cosine curve? How many increments are there?
4 pi.
On, above, on, below, on. There's 4. So you're gonna take this period, cut it into 4 pieces. So that tells me that each increment is not pi over 2 now, it's worth pi. In this one, there was no vertical shift. There's nothing out, there's no d value. Okay? So we're gonna count by pi. So go to our graph. We're gonna go 1 pi, 2 pi, 3 pi, and 4 pi. So this is our graph now. What does the cosine graph look like?
You start on the line.
It starts above, but because there's a negative, we're gonna start here. So we're building on what we learned on Friday.
So every time you do this on a test, you have to label the x-axis.
Yeah. Yeah. So now, I know this looks just like what you did on Friday, but because we changed the x-axis, if I would have transposed this onto that piece of paper that I did a second ago here, what would it have looked like? Oh, anyone?
Wait, I need to see the other one again.
I'm confused
The
on
glass.
the amplitude.
On what?
The amplitude, like is it always one?
No, it's the number in front of x. Or, I'm sorry, the number in front of the cosine or sine word. The amplitude is the number in front.
But this
There's-
one negative one?
Yes.
Yeah, wouldn't it be negative one?
Well, amplitude, it's like, amplitude is never negative. Amplitude means how
Absolute
high
value
off
of
the
that.
x-axis.
Oh, okay.
You're not -1. It's like saying, how big is this room? You don't say it's negative 20 feet long, you say it's 20 feet.
So it's
Okay.
the absolute value of.
It's the absolute value of the A value. So the A value is 1, or -1 if you wanna say -1, but it's, the amplitude is 1 unit. Amplitude is how high off the x-axis you are, and it's a 1. So, this was the original graph of the cosine. If it's gonna take us to get to 4 pi, four increments is gonna, it's gonna take us to get to 4 pi, this graph would have looked like this. It'd be on, and then this would be our next move. And then another pi would be here. So this thing is gonna be what?
Twice as long.
It's gonna be stretched, horizontally stretched. Okay? And then this is what the explanation is right here. If B is greater than 1, you're gonna have a horizontal compression. If B is less than 1, you have a horizontal stretch. Next, let's put it all together. Now, this will make sense more. This is your amplitude is what? 3. This is your A value, 4 is your B value, and D is your 2. Anyone wanna know where C is?
It's,
Anyone
Would it
interested
add
in
to
C?
Sure.
does it get,
why not?
become like in
Would
the
add-
apostrophes?
C is gonna be, in pre-calc next year, you're gonna do C.
That's what means we
I'll show you real quick.
That's what,
We're
when you
not gonna-
add something to T, right?
Yep.
I figured. Yeah, I can't figure.
This is A. This is B. This is gonna be C. And that's gonna be D. You're gonna
Is-
do this next year in pre-calc. This is gonna be called a phase shift, so you're not gonna start your graph here. It's gonna be shifted over to the left or to the right. This would be pi units to the right. You're gonna do this next year. So this year, we're gonna concentrate on this, and this, and we're gonna dabble in the B value. That's gonna change your period, dabble. So next year, you go deeper into these 2 items. You're gonna see some really strange looking B values and phase shifts, okay? As a matter of fact, we just finished the chapter in pre-calc, but here it is. So, your amplitude is 3. Your period, you always take 2 pi and you divide it by the B value. What is the B value here?
4.
4. What's 2 pi over 4?
Half
One.
pi.
A half a pi. So, whoops, half a pi. So what does that mean? That means we're gonna complete the entire cycle by the time we reach pi over 2. So here was your graph. Pi over 2. Here's pi over 2, guys.
First.
So we're gonna do all 4 by the time we reach that. Okay? So now, how are you going to cut this into 4 parts? How are you gonna take pi over 2 and divide it by 4? Does anybody like to divide fractions? I don't.
No.
I do pi over 2 multiplied by 1/4, which is pi over 8. So you're gonna count by pi over 8. Okay? The increments is what you're gonna count by. You take your period and you divide it by 4. And by the way, this has a vertical shift of 2 up. So now, this is what I want you to do. Here's your graph. I like to label my x-axis on the bottom because it gets too messy here.
True.
And it obstructs my view of my graph. So this is what I'll do. I will start at 0. And right here is gonna be pi over 8. And then 2 pi over 8. And 3 pi over 8. And 4 pi over 8. And what did I say 4 pi over 8 is equivalent to? pi over 2. So we're gonna complete our cycle by the time we reach pi over 4, pi over 8, or pi over 2. So now what does this graph look like? We're gonna shift our graph 2 units down. Oh, 2 units up, I'm sorry. It's a plus 2, not minus 2. 2 up. Thank you, Sam. 2 up, not 2 down. Glad you're paying attention. 2 up. Now, what's our amplitude? 3. What does the sine curve look like?
Starts on there.
It starts on, and then where do we go from there? Up 3. Back on, and then down 3, and back on. And this is one full period. Now, I understand it looks just like the other graphs, but by you naming this x-axis, you're telling me that it's completing the cycle by the time you reach pi over 2. If you were to put this graph on here, you would see that it went from 0 to pi over 2, but we wouldn't be able to read it. If we were to cram 0, do you guys understand, from 0 to pi over 2? If you were to label your x-axis and cut this into 4 parts from here to here, it would be nice because you could actually see that the graph was horizontally compressed, but we wouldn't be able to read it. It'd be too hard to read. So that's why we do this. Now, if they want you to do 2 full cycles,
You can do it twice.
you're gonna do it twice. Thank you, Ms. Burback. How would you do it twice?
Keep going.
You could go this way
Or you
another
go
4.
over the axis.
I would probably go left. That's really what they want you to do. They want you to go left. How can you count backwards? Make this negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, and negative 4 pi over 8. And can you go backwards? Just like that. Now there is one more thing I would like for you guys to do. Anyone think they know what, to make a
Go.
perfect graph? Label what?
Your x and y axis.
Label your, we did the x, but we didn't do the y-axis. Why do you think it's important to label the y-axis?
The scale.
To see the scale. You want to know what your amplitude is. So what you could do is call this 1, maybe make this 5. That's enough. You don't have to label every single number. So we are showing that you're 3 units above the x-axis. Okay, see this next problem? This is actually a pre-calc problem, but I figured you guys can handle it. This is what you're gonna do next year. Could you give me, write an equation for a sine function with this given information? If I tell you that how high it is off the x-axis, the amplitude, where does that 1/2 go? In front, that's easy, right? Save the period for a second, the last thing we do. If it's shifted 3 units down, where does that go? -3. So I need to know what B is. If they tell you that the period, so in other words, this graph completed the cycle by the time it reached pi over 2, what you're gonna do is set pi over 2 equal to the definition of the period, it's 2 pi over b, and you're gonna solve for b. That's all you have to do. Set the period that they give you equal to the definition of the period, 2 pi over b, and solve for b. Now, we're gonna cross multiply. What's pi times b? Pi times b. What's 2 pi times 2?
4.
4 pi. These pi's cancel, and what's b equal to?
4.
4. That's the number that would go here. So the bigger the b value, the more the graph's gonna be compressed horizontally versus stretched. If it's a fraction, it's gonna be stretched. So this back side is your homework. Let's start it.
You want me to stop recording?